welcome to our flipped lesson for 8.4. This one is going to be the shortest and sweetest of all the lessons we've done so far. So here we go. What if we have this sequence up here? 1, 3, 5, 7, 9, 11. We recognize it as an arithmetic sequence, and that's fine. We could do this extra definition, but we've already done that. So what we're going to look at today are sums. What if we decided to look at S sub 1, which basically means what's the sum of the first term? Which is kind of weird, but sum of the first term is just 1. And let's look at S sub 2. We look at S sub 2, we're saying what's the sum of the first two terms? We're looking at 1 plus 3, and that's going to give me 4. And we can keep going. We can look at S sub 3, which is going to be 1 plus 3 plus 5. We can add that up, and we're going to get 9. And you know what, just because I'm curious, I'm going to go ahead and look at the sum of the first 4 terms, so S sub 4. So I look at the sum of the first 4 terms, I've got 1 plus 3 plus 5 plus 7, which is 16. And you know what, let's just do one more. How about S sub 5? S sub 5 is 1 plus 3 plus 5 plus 7 plus 9, which is 25. So what I'd like for you guys to do is look at the answer for these sums. S sub 1 is 1, S sub 2 is 4, S sub 3 is 9, S sub 4 is 16, S sub 5 is 25. And you know what? Are you noticing a pattern? Hopefully, when you look at these, you're noticing, that's the same thing as 1 squared. That's the same thing as 2 squared. That's the same thing as 3 squared. So on and so forth. And so we could come up with a possible definition for our sum. We could say, looking at this, we could say, how about if we said the sum of any n terms is going to be equal to n squared. Sum of the first squared. First 2 terms squared. And we could do this, and we look at our first 5 terms, and we can say, well, it looks like that would be true, but how do we know if that would always work to find the 152nd sum? Is S sub 152 equal to 152 squared? How much money would you bet on that? So while we look at this and intuitively feel like this is true, no matter what our n is, we can't really...
Jennifer Giovanoni, please dial 57611.
So we can't really prove it. And so the reason why I'm doing this the night before our lesson is that I want you to start thinking. We can't say this is true unless we can prove it, which leads us to what we're going to do in class. We're going to learn how to do math induction proofs, which will, in class, will be able to tell us whether this is true or whether it's false and ends up not working. So I look forward to seeing you in class. Thanks for joining me for our flipped lesson, and I'll see you tomorrow. Bye.